For P6-11, the hex screw, hex body, we're going to be working with revolves and the cosmetic threads. I keep calling it the thread wizard, but it exists under the whole wizard, so it's thread. And then as an optional, I'll add in a couple notes on the swept cut. Kind of moved away from that. Previous videos have always just showed the sharp V. We're going to do a little more detail. If this was going to be a 3D print, I would want to be able to control those threads a little bit more. So when we go into the revolve, we'll use the body as the example. This is already cut in half. And so what I'm looking at is taking this quarter section and making it my sketch. So if I cut this piece in half and take the quarter section and draw that, I'm going to be able to utilize those geometries to create the revolve. The hex on top, I'm just going to go ahead and make this circular and then pick up the hex. We're 25 across the flats, so that'll give me that geometry. So let's get started with a new part metric. I'll go into the front plane and open up the sketch. We're going to do a center line, vertical, infinite length, and place it on the origin. If it misses, I'm just going to drag it back to the origin. Occasionally, haven't seen it in a while anyway, occasionally the center line doesn't go fully defined. If it doesn't, just grab it, drag it, it'll snap back to the origin, make it coincident. And if not, then we'll just add it manually. So I want to, I'm gonna go ahead and close this off. We're gonna look at this in two examples of what happens when you don't do the center line. So anything that's away from the center line is going to be a cavity or a hole. And so if I draw that first, then when I go to complete the revolve, it won't ask me to close off the sketch. So I'm going to rough these in. And if I miss a little bit, well, we'll figure it out. So I just connect the dots. We'll make that horizontal. Deal with whatever strangeness it does, because the downside to sketching the entire profile is always if things move around, do they move as expected? So with the first dimension, it scales, and it didn't do anything really strange with the geometry. So we can go ahead and start our diameters, and that'll be the 25. And then with the D next to our the dimension, that's telling me that it's automatically going into diametral. So I'm going to bring that one down. We know that the body for the M20 and the 20 millimeter threads, or the 20 millimeter body, are all going to be the same. So a select, control, select. Pick the first one, hold down the control button, select, and select again. Well, my chamfer didn't quite stay, so, oops. Let's control Z the construction geometry. Not ready for that just yet. Let's go collinear. Now drag this down a little bit. Put it in. Now we could always put this in as a separate feature, but one of the reasons that we would choose a revolve is I can get a lot of geometry in one feature. If I was to do this as a boss, I would extrude out to here, and then the center section, and then here, and then go to the next one, and then just kind of keep building up. Or I would draw the center to the full length, and then add the offset for the notches. So it would end up being at least 5 or 6 features. So let's go with the two inside, we'll make those collinear, and they're also both 5 millimeters, so I can set those to equal. And my dimension line there is kind of, or my extension lines are a little bit confusing overrunning that, so I'm going to move that out of the way. We have a 5 millimeter, diameter of 15 millimeter. So we'll pick that back up. Because I did something else with the relations, it jumps out of the diametral mode. And just keep in mind, when you're between the object and the center line, you're creating a radius. When you're on the opposite side of the center line, that's when it jumps to diametral. So 15. And to get out of diametral, then we're going to go ahead and hit escape. All right, so we got 3 millimeters for the height. And I got the midpoint, so I'll zoom up a little bit more. And the 45 degrees. To the first section is 23. And just using the scroll wheel again to move around and create the geometry. So the 25 is from the top to the top of the groove. And then we have the 5 millimeter for the height of the hex. And let's see, I need to put the dimension there, and that should do it. Okay, so everything's fully defined. Now, one of the rules is that if I have more than one center line, then it's going to ask me which to select. And by drawing this piece first, when I do the revolve, it's automatically going to give me the preview. So I'm going to switch this over to a construction line for the example and go to revolve. It says the sketch is currently open, which would make this a thin feature, meaning it would just kind of trace around, have an offset around all of this geometry, and the inside would be hollow. So if I say no and kick that out, I'm going to go back and find my center line. And one of the problems with the duplicate entities is that I'm going to have to find that center line. So I'm going to do a left to right window pick and go back to from for construction, uncheck that, and go to an object line. Now when I do the revolve base, you can see no warning, 360 degrees, one center line, and even if there's more center lines, I've created geometries that I needed to mirror or to create dimensions from, and it just means that this box will be empty. I come over and select it. And at any time, I can pretty much, as long as this is not self-intersecting geometry, I can change that shape. But when I get down to something like that, it doesn't show me the preview because this little nub will overlap into itself. So self-intersecting geometry is not going to be to work. So we'll go ahead and create our shape and put the hex on the top. So back into the sketch. And because we already set it at 25, I can drag this out. We're an inscribed circle. So I'll just get out of that, hit select, select, control, select, and this is one of those cases where we can do co-radial, same center, same radius. Doesn't really matter for our flats. One of them will be vertical or horizontal, just kind of depends on, there's a way that you want to see it. I'm going to rotate over so I can see that bottom surface because that's what I'm going to use to create the extrude. Extruded boss base up to surface. Well, it rotated back for me, so I'm going to rotate it again. Pick that face, and that's going to create the extrude. All right, we'll do the chamfer last. There's not really a number there, so we can pretty much pick whatever we want. Probably 2 millimeters on that chamfer. But let's go ahead and go into the threads. Chamfers and radiuses, as a general rule, I want to do last. All right, so our drawing says M20 but doesn't give us a thread pitch. So whatever we pick, we're going to have to stay with that. So I will pre-select first. I want this bottom edge. And I've already added this to my features, but well, jumped off the screen again. So right at the very bottom, insert annotations, cosmetic thread, and we're picking the edge. If I hadn't pre-selected, I would have to pick that. It's going to be machined threads, and what are the other ones? Straight pipe tap thread. And M20 by 2.5, so just doing a quick conversion to inch, that's about 100 thousandths. That would be 10 threads per inch. The 2.0 is about 80 thousandths, and the 1.5 is 60. So kind of a fine, extra fine, fine, and coarse. So we'll just go with the 2 millimeter. And I want this for a depth. Oh, there's the end condition. Let's just go up to next, and it should find this geometry and terminate. All right, if you show type, when it puts in the note, and I'm not overly fond of the note, they are functional, but I don't want to see the machine threads. I'm going to put usually put other details with that geometry. All right, so that gives me a cosmetic thread. At that point, I have enough information to create the working drawing, except for my my chamfer, but we have enough information here to create the drawing and have our part. So the cosmetic thread, I can make a configuration for a simple, where when we do modeled threads, you want to make the choice because it's going to increase the file size. Speaking of which, might as well go ahead and save. Let's go in to my drive. And one of the things I will note real quick, if you're using the cloud drive, your working folder, we had this happen in the lab the other night, that I really shouldn't be doing this out of the SolidWorks save as, but we'll be able to. This one is for Google Drive. We want to make it offline, access available offline, and that way, if there's a disconnect, that you would still have access to this this folder. So I already created my P6-11 folder. For my project, we're going to call this the hex screw and save it. All right. So let's continue on with the threads. Oh, and I mentioned that we can create a configuration, or I can just hide these, and would have to determine now the thread. Modeled threads are going to make the drawing a little less readable, not my preference. So when we go to find the hole wizard and then the thread, it's going to warn you production quality threads. It's going to be close enough for a 3D print with a little bit of adjustments, but if you need to really dial it in, then the swept cut is going to give you a lot more control. All right, so this is showing me an external thread, so metric tap, and the end condition, let's just go up to selection and I'll grab that face, and I want to see these kind of in detail. All right, so we need to switch to a metric die. The tap is going to make internal threads, so we could use that on the body, but it's not going to be very functional on the external. And so you can see that this thread terminates here, which means that it's not really going to complete. There's going to be maybe a quarter thread before it picks up. So we're going to scroll back up to the offset, 1 millimeter up, probably 2 millimeters down, which is the pitch. That gets me completely off of the geometry, runs, and completely off the geometry at the top. Okay, so let's go ahead and see what that looks like. It has the crest and the root flats. That is a pretty big thread, so we are going to see that geometry with some decent size. All right, so to finish this out, I'm going to go to the front plane and open the sketch. And in this case, I am looking at it from the side. So I want to knock the corners off. Well, this is the corner. This corner is kind of at a 60-degree angle. So if I'm drawing on the front plane, I need to be external. We're going to do both cases, and either one of them will work. It's just you have to gauge the results. So I'm going to start over here, bring that down a little ways. I have a choice of making, putting the 45-degree dimension or just making the two lines equal, and setting a dimension. We'll go with 2 millimeters if you want to see what they look like. I don't have anything to revolve around here, so in this case I am going to have to put in the center line, vertical infinite length, place it on the origin, and we can go ahead and perform a revolve cut, and you can see it kind of knocking the corners off of our geometry. All right, in contrast, if I suppress that, if I were to sketch that in the right plane, then I would want to utilize the interior and go to my dimensions, set my 2 millimeter. I need to set those equal. All right, same process with the center line. Usually I put in center lines first, but it does not have to be the first. So, all right, so same basic process. We're just ending up with our decision tree goes to, do we draw on the inside or draw on the outside? It depends on the plane that you've selected. All right, so I'm going to save this with the geometry, and we're going to see some of the difference here with the when we get over to doing the detail drawings. So I'll worry about configuration suppressions when we get to that point.